Okay, so what would we do if we wanted to do something similar to my last video where we were making an imine, but what if we wanted to take some carbonyl and we want to convert it into um, into an enamine? So what is an enamine, you might ask? Well, an enamine, if we're looking at the words in the actual, or the letters in the word, we have an ene, which might make you think double bond and then amine. So if you thought double bond and if you thought amine, then you are exactly correct because an enamine is just some, we'll give some chain. It doesn't matter again what it is. It could be anything because the only part that we care about is this part I'm going to circle in white. So if you notice, we have our nitrogen that is um, attached to a carbon that is attached to another carbon that has a double bond connecting them. And so we can kind of say or see that this is our amine, and then down here this is our ene part. So going forward, how can we do this from some carbonyl? Well, very similar to making an imine, it's going to follow the same exact process, with the small exception that we have to be careful with how many hydrogens that we have in our amine that we are using. So what do I mean by that? I mean, um, I mean, uh, we need some amine that has only one hydrogen to it, because if you have any more than that, you'll end up forming an imine. Um, unless you have some other sort of functional group attached to our amine that you can kick out. But for example purposes, I'm going to use dimethylamine. Okay, and again, similar to uh, the imine mechanism, we use some acid to get this reaction started. So the only thing basic here is that lone pair of electrons on our carbonyl, so it'll pick up that proton. When it happens, we now have a protonated carbonyl that um, that now, as making uh, our carbon be very delta positive, we are going to take our dimethylamine and now use it as a nucleophile to attack that carbonyl. When you do that, you've attached a nitrogen, and so we're going to look like we have an alcohol. We have an alcohol, and then our nitrogen group that has its two methyl groups and also a proton to it. It also has that positive charge. So going forward, we need to take away that proton. So the way we're going to do that is by using dimethylamine. It's a good base, and we have tons of it in solution. So the extra pair of electrons on dimethylamine comes over, sees that extra proton, pulls it off. We've satisfied the charge on our nitrogen group now. And there's our alcohol. And there is our amine. So at this point, we are close to being finished. We just have to kick off that alcohol. And the way we're going to do that is by first protonating it to water. And we're going to do that with more acid. So acid will be coming from whatever you used in the beginning. It could be your protonated amine, or you could be adding something else. But at this point, we have the extra pair of electrons on our alcohol that will go over, attack that proton. We get to the stage where we have water attached and we want to fall off, and our amine just hanging out right there. So I've added a hydrogen I guess you could call it alpha to our nitrogen group. And the reason for that is because I'm going to be pulling that off with our dimethylamine. So I'm going to be pulling it off because when I do that, I'm going to let these electrons flop down to create a carbon-carbon double bond. In order for that to happen, we have to kick out water. So in the end, we kicked out water, and we've created that double bond that we need for our ene part of our enamine, and we still have our dimethylamine that we have attached on the top.